All right, now we're just going to run through a full problem from beginning to end for calculating start time. This time we're going to do it in the evening, so we're working off of sunset, not sunrise. And we're going to be working with position 43 degrees, 20 minutes south, 133 degrees, 16 minutes east. Again, remember, you would probably not be given a position. You'd be given a position earlier in the day, and you have to advance it forward. Usually, you should advance it to the general time of civil twilight in the closest local mean time listed in the book to you. So like if we didn't know this right here, but we knew we were in approximately 40 degrees south, and in that case, we would open up to April, what did I say, 16th? We would open up to the page for April 16th and look, and we'd see for 40 degrees south, let me zoom in a bit more, 40 degrees south here, in the evening, civil twilight will occur right around 1900. So then we would advance out to 1900 and set that as our DR and use that. However, in this case, we just have our position. So we'll be working off of this. All right, now step one, remember we have to adjust to the proper latitude. So we're gonna set up our table. This time the table is gonna begin with sunset and then civil and then nautical because the order is reversed in the evening from what it's like in the morning. And then we'll set our latitudes up here. We'll know our central latitude is 43 degrees south. And then we'll look into the book to find what our options for the other latitudes are. So you can see, oh, I'm sorry, I used the northern latitudes for here, where we should be in the south. So we come down to here, so we should have actually based it off of this value here, 1755. But we see that our options are 35, oh wait, no, we're at 43. So our options are 40 degrees and 45 degrees. So we're gonna write 40 degrees south up here and 45 degrees south down there. If you want to write it the opposite way, if you think it's easier to have the numbers increasing when they go up, that's fine, as long as you maintain which one is which. I like it easier to have it going this way because I know that south increases by going down, but that's up to you as long as you keep yourself organized. So next we're gonna transcribe the times for each of the twilights. So you can see at first 40 degrees, we have sunset happening at 1728. We have civil twilight happening at 1755. And we have nautical twilight at 1827. Then at 45 degrees south, we have 1721, 1751, and 1825. And so this time, instead of the numbers working as nautical twilight is when the sun first starts to like peek over the horizon where you can see it glowing and that kind of illuminates the horizon and then slowly it increases, we're now obviously working with it in the opposite direction where the sun hits the horizon, sets fully, and then slowly we see its light fade away. And that's when it's fully faded, that is the time of nautical twilight. All right, now with these times, we just have to start setting up our proportions. So we can see this total span from 40 degrees south to 45 degrees south is 5 degrees. And then this span here is 3 degrees, 20 minutes. I forgot to write the 20 there. And we'll compare that to this span versus this span. If we wanted to go from here down to here, that would be fine. I just usually work from the bottom up, regardless of whether that means I'm adding or subtracting. It's what works for me. Do whatever works for you. So firstly, we should find what this span of time is here. You can see it's 7 minutes. In this case, it's 4 minutes. and in this case it is 2 minutes. So we're kind of operating off of smaller values here. Let's see, it's April, so it's generally around the equinox. It's technically it's technically after the equinox, but we're pretty far to the south. So we're in the summertime slightly, and we're very far to the south. We're 43 degrees south. So the time of sunset's going to happen pretty early in the day, and the sun's going to move pretty quickly. We're pretty quickly phased. That's why all of these time spans are both pretty close together, though it happens still over the span of about an hour, and why the difference between the two latitudes is also pretty small. It's also because we're only working off of 5 degrees of difference between the two latitudes. So all of these are going to play a factor. So now we actually set up our ratios. We'll do 3 degrees 20 minutes over 5 is equal to x over 7, and is also equal to x over 4 and x over 2. And without even needing the calculator, I know that 3 degrees 20 minutes is equal to 3.3 repeating degrees, because 20 is 1/3 of a full degree. So then we'll work out the math here. 20 divided by 60 plus 3 divided by 5, we get a ratio of 0.6 repeating, times 7 gives us 4.66. Then we'll do times 4, gives us 2.66. Then we'll do times 2, gives us 1.33. So this we can just round to 3 minutes, and this we can round to 5 minutes, and this we can round down to 1 minute. Then we'll see that's 5 minutes off of this time, so we're going from earlier to later, so we'll add the times here, and we'll get a time of 17:26. That's 3 minutes above this one, so we'll get 17:54, and then 1 minute above this one, so we'll get 18:26. So those are our times for our central meridians at the correct latitude. Now we have to work on longitude. So step 1 is we have to actually figure out what our central meridian is and what time zone we're in. Now we're 133 degrees 16 minutes east. Step 1 is to find our zone description. Now before we begin, we're in the east, so we know we're minus. We'll do 16 divided by 60 plus 133. Divide all that by 15, we get 8.88, which rounds to 9. So we're in ZD minus 9. That means our central meridian is just 9 times 15. 9 times 15 gets us 135. Okay. And now we can set up, draw it out a little bit. So, yeah. We've got 135 degrees east here, and we've got 133 degrees 16 minutes east here. The sun moves this way, so sunset is going to, well, I guess actually in this case, it would be easier to draw it as the sun passed through here at LAN, obviously, but then it's going to go all the way over, and then, if this right here is sunset, it's coming closer, closer, closer. It's going to hit 135 east first, and then it's going to continue as such until it finally hits 133. So everything is happening later in the day for us. Wow. All of that was off camera. I'm sorry. Here's 135 degrees. Here's 133 degrees. So we are west of our central meridian, and I'll just draw that out again. That's not it. God. Whatever. Sunset is first going to hit around here. Then as the sun moves further away, way off this way, it's going to continue closer and closer and closer until sunset finally happens at 135 degrees east, and then continues on and on until finally sunset happens at 133 degrees east. So we know what's happening first at our central meridian, meaning that all of our times are going to be later in the day. So now we have to just set up what our difference of longitude is. So we'll do 135 degrees, 0 minutes east, and then 133 degrees, 16 minutes east. Find that. First we carry over the 1 there. Get 60 minus 16 is 44 minutes, and then 34 minus 33 is 1 degree. So we're 1 degree 44 minutes away from our central meridian. We're going to convert that to all degrees. So 44 divided by 60 gives us 0.73. So we're 1.73 degrees away from the central meridian. We're going to multiply that by 4 to get our time in minutes. So plus 1 times 4 gives us 6.9 minutes, which we'll round to 7. Okay, so the times of sunset, civil, and nautical happen 7 minutes later for us than they do at the central meridian. So now we're going to set up, we're going to carry over our time. So we had 1726, 1754, and 1826 for sunset, civil, and nautical. And we just add 7 minutes to each of these because it happens 7 minutes later for us. So for that, we'll get 1733, 1801, and 1833. So those are our actual times of sunset, civil twilight, and nautical twilight at the exact position that we were working off of. Now, the only final step we got to take is we have to find star time. Remember, star time is halfway from here to here and halfway from here to here. So we find the total difference in time between 1733 and 1801, which is 28 minutes. Yes, 28 minutes. Divide that by 2, so that's 14 minutes. So we're going to do 14 minutes after 1733, which gives us 1747. And then for the final time, it's going to be 1801 to 1833, which is 32 minutes. Divide that by 2 is going to be 16. So then we're going to add 16 minutes to 1801, and we're going to get 1817. So the question will usually be asking you, what is the time of sunset and what is the time of star time? What is the period of star time? And you could say sunset is going to happen at 1733, and star time is going to occur from 1747 to 1817.